Greeting to lecturers. I am Lo Chen with meeting number 75484. Our team is Group 19, Cake Bakeries. Group member including Alex, Muhammad Zikris, and voters as shown in this slide. In this video, we will explain the purposes of flow automations of cake bakery system for cake craft bakeries.
Hello, I'm Muhammad Zikri bin Mahde, here to give a little bit of introduction about our company. Our company, Cake Craft Bakery, have come a long way and have fully integrated ourselves into this industry over our incredible 20-year journey thus far. We have gained recognition not only for our dedication towards excellence, but also for a wide variety of cakes and flavors. In our mission towards aiming for progress and growth of the company, our latest project is taking a bold step to fully automate our cake manufacturing processes while carefully balancing tradition and technology. This allows to standardize our cake production to be exported to the Middle East. Moving on to our objectives here, the three main objectives are: number one, to determine the most suitable manufacturing monitoring methods for the fully automated cake manufacturing system. Second, to differentiate between centralized and decentralized approaches in the context of automated manufacturing processes. And finally, the third, to propose the costing structure for the implementation of new manufacturing systems dedicated to the production of cakes.
For this part, I will explain briefly about our literature review based on our reports. So the first is centralized automation. Centralized method allows for more effective resources allocation, uniform processes, and the employment of robot arms for hazardous activities. Second is about the decentralized automation. Decentralized automation in the baking cake factories, on the other hand, may entail the spread of control and decision making, process and taking lessons from decentralized models in supply chain and manufacturing system. Second part of our literature review is about manufacturing monitoring work. Pulgan et al. 2020 provide insights into automating temperature control system in cake heaters. This study emphasized the use of microcontroller-based automation for precise temperature regulation. Chen et al. 2020 emphasized the need of partially decentralized and hierarchical management system for smart factories. These studies focus the prevalence of decentralized system and advocate for collaborative trust blockchain-based control transfer mechanism in industrial automation. The third literature review is about manufacturing system in a factory. Mittal et al. 2017 defined threats, technologies, and enabling elements of smart manufacturing. The goal is to initiate broad interdisciplinary discussion within the research and industrial community. Second is Pellegrini et al. 2006 highlight the importance of communication technologies, focusing on the utilization of wireless network at a low level of factory automation system. The last part of our literature review is about quality control in the factory. Thalapatra and Udin 2019 analyzed total quality management (TQM) implementation barriers in the garment industry in developing nations. These findings shed light on problems and priorities in quality management. Lee and Lee 2017 emphasized the importance of investment, inspection, and incentive in the management supplier quality. This study is focusing on ensuring the incoming items are of high quality.
Next, I'll be talking about monitoring works that are done during the manufacturing process. Manufacturing monitoring refers to the systematic and ongoing process of overseeing and controlling various aspects of the production process in a manufacturing setting. The primary goal is to ensure that manufacturing operations run smoothly, efficiently, and in accordance with established standards and objectives. Monitoring can be classified into two types: monitoring for variables and monitoring for attributes. The three monitoring methods are: first, offline monitoring; second, online in-process monitoring; and third, online post-process monitoring. First, offline monitoring is performed away from the manufacturing process, and there is generally a time delay between processing and inspection. It's normally done using sampling methods. From the figure here, assume that the incoming work parts are raw ingredients of the cake. It then goes through a series of processes to be produced into a cake. After cake production is done, the cake will go through offline monitoring before packaging is executed. A decision will be made whether to accept or reject the cake from the monitoring. Next, online in-process monitoring is done during the manufacturing operation. The monitoring procedure simultaneously measures or gauges the dimensions as the parts are being made. Based on the figure, the ingredients will be processed and simultaneously monitored before the cake is fully produced. As a result, problems with the product's quality can be changed and resolved before it is finished, as data from the monitoring process is collected concurrently with the manufacturing process. Some sensors that are used in this case are thermal sensor, weight sensor, and a visual inspection system. Lastly, after the production process is finished, in the later stages of post-production, online post-process monitoring occurs. After the production process is complete, it focuses on assessing and analyzing the final goods or outcomes. It involves gathering information about the features, quality, and performance of completed goods. The fact that this is integrated with the manufacturing workstation keeps it classified as an online technique. The raw ingredients are processed and inspected right away, leading to the sorting of the cakes that are acceptable and those that are defective.
Manufacturing system is one of the important part, as manufacturing system refer to gathering of human resource integrations equipment which designed to carry out the progress and assembly operations on a starting material or part to a final product. In the manufacturing system, we have involving the group technologies. Group technology, also known as a approach in which a similar parts are identified and grouped together. The benefit of these group technologies to our company including improve the productivity and manufacturing efficiency, which reduce the lead time. Group technology also highly recommended as our company need a high in process inventories. In our proposal, cellular manufacturing is the most suitable layout, as product varieties and product volume for our company are in the medium. Flexible manufacturing system is one type of the machine cells which has been used to implement. The most suitable flexibility manufacturing system in our proposal is linear taps, as it is more efficiency and economically safe. The figure above shows the flowchart of our proposals for this manufacturing system. In the manufacturing system, it involves a few machines, such as egg breaking machines, mixture machines, dough dispose machines, oven, cooling tunnel, cutting machines, cream injection machines, UV sterilizing machines, and baking machines. In these proposals, the manufacturing system and machines will be located at the middle of the industry. The office, meeting room, and storage and others will locate at the side of the industry as shown in this diagram. Furthermore, our proposal for the lead time of a single process estimate to be 200 minutes. The productions of the cake unit estimate to be 360 units of cake per day.
Quality control system. Quality control and quality assurance are two essential components of the quality management system, and together they contribute to ensuring the delivery of high-quality products or service. In context of cake manufacturing, the tricky method can be employed to enhance the quality and consistency of final product. Here, we must identify the parameter of making the cake. For example, we must know the ingredient to make the cake. First, amount of flour, amount of egg, amount of baking soda, amount of flavor cake, sugar, milk, olive oil, and butter. To ensure cake quality, we must monitor several aspects including baking temperature, baking time, sugar amount, flour quantity, butter quantity, mixing speed, ingredient balance. These are all aspects are just to make sure the cake that we make have a good quality. For inspection technique, we use a few type of sensor to make a cake. First, we use metal detector to detect the metal in an ingredient. Second, we use humidity sensor to identify the object enclosed. Third, we use thermosensor to monitor the temperature during the baking process. Last, we use infrared sensor to measure the final dimension of cake.
What is centralized automation system? Centralized automation system in a cake baking factory refers to the integration of various automated processes and control into a single centralized system to manage and monitor the production of cakes. This central hub serves as the brain of the automation system, coordinating and managing the connected devices or systems. What is decentralized automation system? Decentralized automation system in a cake baking factory involves the distribution of automated processes and controls across various sections of the production facility. This allowing for more localized monitoring and management of the cake production process. This control and decision making are distributed across multiple nodes or devices within the automation network.
Cost estimation also an important component in the proposal as it can be used to estimate the minimum cost of a unit of cake. The cost analysis have including the labor cost, electrical cost, water cost, raw materials, rentals, and other costs. The annual total cost estimation is around 1,057,946 ringgit. This graph shows the benefit cost analysis. In our proposal, Craft Bakery will start to earn money when 35,265 units of cake have been sold out with the price of 30 ringgit. In our proposal, the total annual cost estimation to be 1,057,946 ringgit. However, in our research, the craft bakeries can produce 7,200 units of cake in a month, which can carry a benefit of 1,534,054 ringgit in a year.
For conclusion, our company applied the online and offline manufacturing system. By doing this, the quality of cake can be monitored easily and the best product can be produced. We also use a flexible system and Taguchi method to make a cake. We also propose a decentralized approach in the manufacturing of this company, which is expected to provide both economic and non-economic benefit. After considering all cost and cost-benefit analysis, automation is chosen as the preferred manufacturing method because it is expected to provide the higher return on investment.